I would welcome our own Dr. Manoj Chawla sir, who is a very active and passionate diabetologist. Everyone knows him. He is a director and consultant at Leena Diabetes Care Mumbai, a diabetes care center, which is not active only in clinical areas, but also in research. The most advanced technologies. Sir knows every technology in the country as the first group of doctors who knows about the technology. And he's here today to talk to us about another interesting topic of glycemic variability and its clinical implication and role of generation 2 basal insulin. So over to you, Manoj sir.
Thanks, Anjali. And I had the privilege of being introduced by you twice, yesterday as well as today. Right? And it's good to see bright smiling faces this morning. I'm not a morning person, so extremely difficult to push.
No, but you're looking as bright, sir.
Well, the problem is that we haven't had the breakfast at Westin or wherever, or the coffee and all those things. So
no, I don't think you need it.
Don't? Okay. I start by looking for my presentation somewhere. I think I probably have the right one. Yes. Okay. So let me start again by thanking the organizers at IDEC for inviting me to speak. Well, this is a pharma session, and I have a speaker contract with Sanofi for this conversation. And I'll be speaking on glycemic variability, the clinical implications and role of second generation basal insulin. And the overview of today's talk is, again, revisiting the concept of GV, TIR, and clinical implications. Well, a lot of this we covered yesterday actually in the EBM masterclass on time and range, but we'll be taking through things to more specifically and addressing the connect with the new basal insulins. We'll also review the global recommendations on TIR. How do we really address glycemic variability with basal insulin therapy, and then comparing the benefits of the second generation basal insulins. Now, we've actually moved in our understanding and our focus of managing diabetes from triad to hexad. Of course, if you do a literature search, you will see that the hexad actually can be used differently by different parameters. So your fasting, postprandial, and HbA1c were the original triad. Today, as we expand the parameters that we look at in managing diabetes, we move from fasting PPA1c to hypoglycemia, to nocturnal hypoglycemia, and glycemic variability. You see some other parameters used in literature, and you'll come across as quality of life, I think, which is also important. And you will come across as aspects also on other metabolic parameters, which is looking at vascular health and so on. So we, in today's conversation, are focusing beyond fasting PP and A1C at looking at GV, which I think is extremely important, and an important part of GV today, or as we say that today, current recommendations are actually doing CGMs and TIR and structured SMBG. The most important aspect of that is actually to avoid hypoglycemia, and hence looking at hypoglycemia both in totality and specifically at nocturnal hypoglycemia. So what really is glycemic variability? Well, it refers to the fluctuations in blood glucose levels, both the peaks and the troughs. There are two kinds of variability that we talk about, actually. One, which is the within day. So what happens to the blood sugars within a 24-hour period, the intraday variability, and then the day-to-day or the inter-day variations. And both of these are important. The inter-day variations is actually what we refer more to the variability. The intraday variability is what we refer more to a pattern that we see in individual, whether it's your post-breakfast, which is high, or post-meals, or the nocturnal highs, and so on and so forth. So that's the variability or the pattern that we want to look at. How is it relevant? Well, clear evidence that this variability leads to high oxidative stress, and of course, leads to increased risk of severe hypoglycemia. In fact, every time we talk about using either CGMs or structured SMBG to better manage our patients with diabetes, the first dictum there is minimize the variability, minimize the interday and the intraday variability before you do anything to bring down the exposure of the sugar values, because unless you do that, you're going to be pushing your patients into hypoglycemia. Establishing glycemic variability even if the A1C is controlled. Now, again, yesterday we showed multiple examples of how patients with similar A1Cs could have completely different glycemic profiles. And here again, we are depicting the many faces of an HbA1c 7. You could have individuals who may have completely in range levels. You could have those who are only about having 63%, and you could have somebody who's spending a lot of time in high, but yet landing up getting an A1C of 7 because of the balance between the highs and lows, which is probably the worst scenario. So you want to actually start looking at glycemia more closely, which to pick up the drops or the troughs and the peaks that you see in the movement within a 24-hour period. Now, this can be possible with a good frequent SMBG, but very often it will have its limitations in picking this up, and best ideally picked up with any of the CGM tools. But important for us to acknowledge the fact that GV is an important aspect of managing diabetes. Our patients go through glycemic variability, and wherever possible, we should be looking and picking this up. Which gets us to further understanding the concept of time in range and what's above and below from the in range. Now, people with diabetes should at least spend 70% of their time within the range, and the larger range for most people with type 1 and type 2 diabetes is 70 to 180. You will have separate ranges for people who are elderly and comorbid conditions where you have more relaxed targets, and then little more stringent targets for people in pregnancy where you're talking about 63 to 140 and spending as much more time within the range as possible. Which means that for the larger population, you're talking about at least 17 hours a day to be spent within this time range. As depicted here, what we want to do is increase the glucose target in range, which is 70 to 180, so more than 70 hours. Do everything through lifestyle, medication, education, monitoring, everything to increase this target glucose in range. Minimize what's above the range. So we're talking about level 1 and level 2 hyperglycemia, which is 180 to 250 and more than 250. Minimize that. And very, very important that we minimize the target below range, or TBR or TBT, where we are avoiding any amount of sugar dropping less than 70, and of course preventing the level 2 hypoglycemia, which is less than 54. Why do we really need to do that? Now, I don't need to tell anyone why we need to avoid hypoglycemia. So avoiding hypoglycemia is extremely important. But overall, why do we need to really improve the time in range? Because now there is strong emerging evidence that TIR deranged by 10% would increase the retinopathy risk by 64%, nephropathy risk by 40%, and neuropathy risk by 25%. Of course, a lot of this data comes as statistical models from the DCCT study, and analyzing that and talking in terms of TIR, which was based on those times on SMBG. But a lot more studies being done around the world are now gathering evidence both for microvascular as well as for macrovascular complications through means of carotid internal media thickness. So clearly strong link emerging between TIR and complications. So let's again look at the global recommendations on TIR and how things have changed. So we moved from HbA1c towards time in range, but as I keep saying, it's not one versus another, it is all together. So SMBG, HbA1c, and time in range are all going to be forming parts of our armamentarium within the monitoring portfolio. So the first expert panel in 2012, where the target range is kind of defined. So this evolved in 2017, but there were no unified recommendations. Still at 2019 ATTD, there was some consensus on the international group coming together and telling us about the time in range. The ADA accepts that and puts it in their supplement 2020. You had the ACE as well as ACE talking about CGM assist in reaching glycemic goals safely. 2020, the ADA talks about advocating the use of CGM in various patient profiles. And 2021, clearly acknowledging that CGM is an important tool for hypoglycemia prevention. The ATTD 2019 recommendations on TIR for different diabetes populations. We mentioned this about the targets in the larger type 1 and type 2 diabetes population. Those with older and high risk will have less stringent goals. So you're okay with about 50% time in range as target. For pregnancy in type 1 diabetes, more stringent targets, and the levels change from 63 to 140. For those with pregnancy in type 2 and gestational diabetes, you still don't have the exact targets. It's evolving there, But yes, you're talking about, again, keeping those sugars there in 63 to 140. How much percentage is something that we all need to gather and generate more data for. ADA has made important updates to adding time in range and more. And I'm happy that within our country itself, every conversation today is now talking about TIR and enlightening physicians and patients alike on the same. So TIR is associated with risk of microvascular complications, can be used for assessment of glycemic control. Additionally, time below target and time above target are useful parameters. The another important thing that TIR really does is it's much easier to understand from the patient's aspect. Even today, after several years of using HbA1c, there seems to be some disconnect between what we understand and what the patients understand about HbA1c. We want a target of less than 7 and below. Patients still understand the absolute numbers of 140s, 130s, 160s. But when you talk about time in range and the concept to the patient, and you show them that we want you to be spending at least 70% or 17 hours of your day within the range, and that's how it works, the acceptance is better. They get more involved in wanting to increase those numbers, because that's what is grilled in most minds about improving those numbers. Let's move on to addressing the GV with the basal insulin therapies. There would be an argument for suboptimal clinical utilization of time and range. So some food for thought this morning is, as TIR is important yet seldom measured, why not go for treatment solutions which take care of TIR even though not continuously monitored? Now, I would love to say that let's start doing CGMs and TIR in every patient, but every forum there will be an argument about affordability, self-pay market, our patients can't do it, rural versus urban, and so on and so forth, and limited resource setting. Accepted. So where there would be issues in individualizing on the basis of CGM, let's use the evidence that we have and use the best therapies on the larger assumption that these therapies are reducing the time in range. And that's where we have evidence for basal insulin effectively addressing the glycemic variability. So basal insulin today has the potential of reducing both the peaks and troughs. The peaks are caused by the glycemic excursions, the troughs are caused by hypoglycemia, especially when you have longer fasting periods. Glargine can effectively control postprandial excursions by hitting the base of the fasting. And that's something that we often ignore and forget. Optimizing basal insulin therapy is the root of actually improving the overall glycemia. If you keep the fasting sugars at 130 or 140 and be satisfied, you're not going to get great postprandial. But target the fasting sugars at 90 and 100, and there's a very good chance that your postprandials are going to be way below 180, and that's the target that is anyway set by ADA and various other associations as well. In terms of avoiding hypoglycemia, clear evidence for glargine as compared to NPH or premix insulins in terms of preventing those drops. Finally, let's move on to comparing the second generation basal analogues and how do they really score in terms of the glycemic variability and time in range. Now, this is an euglycemic clamp study which showed lower variability when we compare the two new basal insulins, which is glargine 300 versus degludec 100. And here we are able to compare the glargine 300 in green as compared to degludec, and one is clearly able to appreciate that when you look at the glucose infusion rate in this euglycemic clamp study, you see lesser amount of intraday variability, as you can appreciate here, for glargine 300 as compared to the little peaks that you can still see in this particular study, degludec 100. This euglycemic clamp study concluded a 20% lesser within day variability for glargine 300 as compared to degludec 100. Now, you also get more evidence. This was an independent new PKP study. Sometimes we keep talking about the company-sponsored studies, and you'll have each company showing their own data, supporting their own insulin. So it's always good to see some independent data as well. Now, this was an independent study which is further demonstrating lower variability with glargine 300 versus degludec 100. And then again, when you compare that, 22% greater peak with degludec 100 as compared to what you see for glargine 300. You again look at the data for the glucose infusion rate and appreciate the 23% lesser variability in favor of glargine 300. We move on to look at a CGM study in type 2 patients, which is going to compare the time in range for, again, glargine 300 versus degludec 100. Now, there isn't there isn't much for us not to believe when we say the generation 2 basal insulins clearly have a better profile and lesser hypoglycemia, especially nocturnal hypoglycemia, as compared to the first generation basal insulin like glargine. So glargine 300 and degludec 100 clearly have better evidence, but there is now generation of evidence between these two new insulins, and that's what is interesting to see. So in this CGM study, the objective was to compare the efficacy and safety of glargine 300 and degludec 100 on glycemic control using continuous glucose monitoring. Randomized crossover study with 30 small population group, but 30 type 2 diabetes patients once daily. You're doing CGM for 5 days on each of the insulin treatments. You're trying to look at your efficacy endpoint as the time spent within 70 to 180, which is a standard time in range. Now you start seeing the time below range, and you appreciate here. So in terms of the time in range, you didn't get much difference between both these new insulins, but there was some appreciable difference in the time and below range for glargine 300. So time below range was markedly lesser. Degludec, you still had some portions where it was dropping below range, but that wasn't the case for glargine 300. So comparable TIR for both these insulins with markedly lower time below range for glargine 300. Now you look at another study with again flash glucose monitoring between the two to compare the efficacy and safety again between these two insulins. Randomized crossover study with 24 type 2 diabetes patients again on either glargine or degludec. Even smaller, a study with 12 patients in each group, but again interesting each data that is coming up. Again, the same efficacy endpoint by the mean target range between 70 to 180. Now, what you appreciate in this YAMA-based study is the percentage of time in nocturnal hypoglycemia again with glargine 300 was significantly lower than that with the IDEC, and you're able to appreciate the degludec in the darker shaded bars as well as glargine 300 in the open ones, and you see the percentage of time within hypoglycemia, especially in the nocturnal period, is higher in the degludec group as compared to the glargine 300 group in the open end bars. You see the data for through the day, you don't see greater differences, but clearly more difference seen in the nocturnal period. Then you had the OneCare study, which is the real-world evidence in adult type 1 diabetes patients using CGM. Those who were previously on any first-generation basal insulin, they had a switchover to the initial treatment period for 24 months. They switched from first-generation basal insulin to either glargine 300 or degludec 100. And then this is something which happened for any time between the 24 months of the study, and then you had the active treatment period where you're looking at CGMs for the glargine 300 switchers or the degludec 100 switchers, a 14-day CGM period for these patients. Again, the primary endpoint was looking at the time in range and some secondary endpoints of percentage time above range, below range, and safety aspects. So when you look at the data for this study, you look at the time in range profile for glargine 300 versus degludec. So you see the full day period in type 1 adult patients. You see similar TIR, similar time above range and type below range for both these insulins. So really nothing in this study to differentiate in the type 1 population. When you start looking at the night period, you start seeing some subtle differences which are favoring glargine 300 for time in range, both in the 70 to 140 segment and in the 70 to 180 ranges. You see some appreciable difference in favor of glargine 300 as compared to degludec 100 here. So the OneCare study concluded that in real-world setting in adults with type 1 diabetes, the effectiveness and safety of both these insulins was similar, and in those switching from basal insulin. However, more people on glargine 300 remained within the target glucose range, especially in the nocturnal period versus degludec 100. So some subtle differences which you're able to appreciate, and this brings about both the importance of looking at time in range and choosing the right kind of newer insulin to avoid hypoglycemia. And that's really the main advantage of choosing the second generation basal insulin. Let me conclude by saying that glycemic variability is associated with increased risk of severe hypoglycemia, diabetes complications, and reduced quality of life. As time in range is important but not very often used, it's recommended that you choose therapies with proven benefits of improving your time in range and especially reducing hypoglycemia or time below range. Second generation basal insulins clearly seem to be better than the first generation. And among the second generation, glargine 300 is showing is lesser risk of hypoglycemia, especially during the titration period, and some reduced glycemic variability and nocturnal hypoglycemia as compared to the other second generation basal insulin. So with that, let me conclude and thank again the organizers for inviting me this morning here at IDEC. And I wish the rest of the conference all the best, and taking this opportunity, as I can see that I have some time here for completing a very, very happy Teachers Day. And it's been it's an absolute tribute to speak and contribute in any manner for spreading awareness and education, especially on this weekend of Teachers Day. So thank you, and I hand it back to the organizers and Dr. Anjali and Archana.
So good morning, Manoj. Excellent talk, Dr. Meena Chabra from Delhi. And I have a question for you, Manoj, that we often see when we are doing CGM, that you have a type 1 who's dipping between 3 to 4, right? And then getting up with very high sugars. Even when you decrease the dose of basal, which is usually U100 glargine, you will still have a DONS phenomena and a high fasting. So, you're catching them in CGM. Now, do you think shifting to Toujeo U300 would be beneficial in patients who have this pattern? And second question is, you did not mention that higher doses of U300 glargine are needed, at least 20 to 25% higher doses. So do you agree with this, that yes, higher doses are needed? So when we talk about benefits as far as difference in price is concerned, you need higher doses, and it's written in their own product, monographs.
Okay.
2 questions.
Good morning. Thank you, Dr. Meena, for those 2 questions. And let me start with the second question first on the higher dose required for glargine 300 as compared to glargine 100 or degludec. Yes, absolutely agree that all the studies to date have shown the higher need for this concentrated insulin as it continues to be working for a longer profile, has a flatter PK profile, and the dose requirement is found to be higher. However, that does not minimize the benefit that we see in reduction in hypoglycemia. So hypoglycemic reduction, especially all the evidence for the titration period, as well as in general with the real world studies and other CGM randomized clinical trials showing reduction in nocturnal hypoglycemia between these 2 insulins. Now, some may say there are very subtle differences, especially in type 1, but there are some differences. Having said that, yes, 20% more dose required is something that we need to be aware of. In terms of costing, I think if we compare the cost currently at what these insulins are available, even probably glargine 300 at a 20% higher dose may still be costing less than degludec in India at least. So in terms of costing, I think I will leave it to people to analyze the cost and see the benefits. But the benefits in terms of reduced hypoglycemia is definitely there. Yes, in a lot of patients, you will have to use higher dose, and that is to be aware, and that's a good point that you brought out. I move to the first question that you asked about the patients who may be on glargine or any other insulin and having a dip and then a rise. So dip between 3 to 4 and rise. It is worthwhile to shift them from the first generation to second generation basal insulins like Toujeo. Having said that, is every such patient, especially with type 1, going to respond favorably the way we expect? It may not happen. So in spite of better insulins being available than before, you may still see a pattern where you may be able to minimize the drop, but you may not be able to do much about the fasting hyperglycemia. So you may be able to prevent things going below 80 or 75, but you may still end up seeing a 140 or 150 in the mornings, something that you want to avoid in your type 1s. And for those patients where you may be stuck with such profiles, ideally that's where the place where insulin pump therapy comes in, because then you're able to individualize and fragment the different basal rates based on what you see for that patient.
Thank you. If I have time for another question, organizers.
I think so. We have 2 minutes,
Yes.
and the others haven't woken up yet.
So, Manoj,
Yes,
this
Dr.
is regarding technology. I'm sorry. I want to ask you that when we are using Libre Pro, so the memory is in the sensor, right? So you can read with any reader. I mean, you can do that, right? Now, even if sensor gave trouble or the reader packed up, data from other sensors is not affected, right? So when you're using Libre, the memory is in the reader. Is that right? This means if reader is not giving data every 8 hours, the data is lost. So how do you manage this? Suppose I'm using the same for many patients, what will happen to the data?
Okay, so if I got the question right, your question is about separately about Libre Pro and Libre?
I
or only
wanted to
about...
ask you that suppose Libre sensor and Libre Pro, right? So
two
where is
different
the
things.
memory?
Dr. Meena, two different things. For
Yeah,
Libre
that's something.
Pro,
Where is the memory?
right. So for two different things, it's not only about where the memory is, it's also about how the software is programmed and what restrictions the company puts on the usage. So when you talk about the Libre Pro, you're right that you can use one scanner with as many number of sensors. If the sensor is removed and lying next to your table, a patient sensor, you can scan that even after a month with the same scanner. Every time you scan, it's going to ask you that this has data. Do you want to overwrite that?
Right.
You choose yes, and then you can scan any number and you'll see the data. Now that's the Libre Pro model. When it comes to Libre, it's a completely different system where that's also called as intermittent scanned CGMs. So you require your patients to be scanning with that scanner to be able to record the data.
That's what I'm asking, Manoj. So every 8 hours they have to do it. Otherwise,
they have to. When they don't do it, you get a break in their AGP. So when you come across a Libre data which shows breaks in the AGP, that's clearly showing that patient has not scanned every 8 hours. Also, the patient gets the number of scans that they do. So when they use an individual reader, there are a lot of statistics that you actually teach them to start seeing, and their number of scans is mentioned. Now we say minimum 3 scans. I don't think they lose anything in doing more than 3 scans because it's obviously easier for them to keep a track on the sugars. But when they don't do the scan, and that's only limitation of the Libre. However, the newer generation Libre sensors are minimizing this and coming down to only need for 2 scans per day, but they have to scan it.
Okay, so
may I add something? So correct me, Dr. Manoj, if I'm not putting it right. What I understand is that the data doesn't get lost. See, the Libre reader has the analytical power of analyzing the previous 8 hours data. So if you are scanning, let's say 10 hours later, so it will analyze the last 8 hours data and give you the system. But when you are reading with the software, as you rightly said, which is not available with us right now as an official licensed product, but if at all we get that AGP recorded from the sensor through the application or software, we don't see the data lost or we don't see breaks.
No,
Even if
Anjali.
the patient
Anjali, the data is lost. So sorry, let me correct you here. That software is available widely, even though not through the official channels.
Yeah, I know,
but so if you don't scan it, and that's the fallacy. It's not that the data is there even if you. So if you don't scan it, you lose the data. So as you said, if somebody's not scanned it for 10 hours, you will get it only for the last 8 hours. The 2 hours data will be lost to see and will be lost on the software also. You will not get it.
So Manoj, if I've got it right, make sure that the sensor is scanned by the reader every 8 hours.
Minimum every 8 hours. Yes.
Yeah.
I'll go back and check, but my experience is that the AGP, I have got patients who not able to see it on the reader. But
I'll send you the AGP profiles where patients have missed it, and Anjali,
I've seen that. So
go ahead and verify, but unfortunately that seems to be the problem unless they overcome some
Dr. Anjali, that's why I brought this up, because we've seen lost data, and since Manoj is a man of technology, I thought I'll take this.
No, I think everybody's using technology. I'm no man of technology. There are limitations. We're moving ahead and there are limitations, and we're looking at better and better technologies coming in. I can just tell you all that we have at least 5 other companies in the CGM space which are going to be making their products available in India in the next 6 months. So it's very exciting, and we'll see a lot of improvement. Good
morning, Dr. Benny.
Great. So we had a wonderful session on glycemic variability and the clinical implication of it in using the generation 2 basal.